That's thrilling, isn't it? I paid a fair amount of money to get that too. So I have the rights to stream that here. So before any of you start worrying that I'm going to get DMCA'd with that, I actually ponied up the cash. So, what are we going to talk about today? We're going to talk about the new Unity input system, which is not really all that new. But I've been playing with it, and I dealt with a problem that I've seen a lot of people suggest is a kind of a showstopper for them. So maybe today we can get a little bit into why I don't think that should be a showstopper. Specifically, it's click and drag. The design of the new Unity input system seems to be largely driven by player control. So if you're going to get online and you're going to be in a first-person shooter or something like that with a lot of massive multiplayer as well, or even third-person, the demos and the tutorials that you see online for this new input system mostly seem devoted to that type of user experience where you're interacting with a player character and not so much where you're interacting with the objects in the scene. So when you use the old system, all you had to do was put a collider on an object, and then if you press the mouse, you could do a drag event, and that was pretty easy. What you have to do now is a little more complicated. So let's see how far we can get into it. Now, it's a little sluggish sometimes to use this thing, so I'm going to have to ask your indulgence on how rapidly we can accomplish anything. I'll try to stay out of the way down here in my cubby in the lower left, my lower left, your lower right. But let's see how far we get. Now, for openers, you have to install it through the package manager. A lot of us think the package manager is not necessarily a great leap forward, but there's no way out of it. So you go to the package manager. You wait for it to phone home, I guess. And then once the package manager comes up, you get a chance to scroll along and see what's out there. This is one of the reasons that a number of us think the package manager is not a raging success, is that it kind of runs like a pig. Another reason, while I'm waiting for it to do its thing, and I'll mention that I'm not wild about the package manager, is I think there are other things they could have been working on, like improving some of the documentation. Okay, so here we are at the input system. You simply click on it on that list, and it will sluggishly come up and tell you that it's available. In the package manager, generally on the right hand side, you get these helpful explanations as to whether or not it's been verified with a certain release and so forth. I always try to stick to a fairly recent minor number release of the youngest, long-term support version of Unity. If you're not familiar with this, remember that, or you need to know that Unity is released in multiple versions, all of which are considered active at any given time. They deprecate them and bring them to end of life periodically, but there's no way out of the fact that they're always releasing new ones, and so the question becomes, well, which one should I use? The answer is the most recent LTS, long-term support. The reason for that is a feature in the LTS version won't come out of that version. They'll continue doing bug fixes and they'll do new releases of that LTS, but they won't take a feature out. Until something becomes LTS, it might lose features it has in subsequent versions. So the latest LTS is 2019.4, and then there's a number after that, of course. I think they're up to 21 or 22. I'm going to use 18. Those third numbers, the ones that I call minor numbers, they don't mean much in terms of behavior. They'll include bug fixes, I think is what Unity says. So I'm going to be using 2019.4.18. You can see here it says it's 2019.4 verified. So let's go ahead and install it. It's pretty simple. You just click this button, and then you do the thing you do more than anything else with the package manager. You wait. And, there's some speculation that one of the reasons everything has become a little sluggish with good old Unity is that we're all at home and we've got nothing else to do but work with our Unity projects. So let's see how quickly we can get this thing installed. In other demonstrations that I've done for this, I tend to do the installation ahead of time just because of what we're experiencing right now. You can see there's a little bit of a progress meter. It's crawling along. That's actually a little peppier than it's been in some instances. Now, while we're waiting for this to finish, I'll tell you what we're going to do next. We're going to go into the settings, and we're going to explicitly state that we want to be using the input system, not the existing input class. And you can actually make three choices. You can ask to use the new input system, you can ask to continue to use the old one, or you can use both. Now, Unity has straight up said that they haven't done extensive testing when both are enabled. I've done a little bit of testing with it, and it can get you into some confusion. I haven't found any outright bugs, but where you might want to conventionally adopt method names that resemble things you're used to, like on mouse down and so forth, the input system presently has no on mouse down method, but the old one does. And so if they're both active, you could get into a name collision that you don't want to have. Okay, notice what it's saying in the warning. The project is using the new input system, but the platform backends are not enabled yet. Do you want to enable the backends? Doing so will restart the editor and disable the old Unity API. I'm just going to say yes, but we'll go look at it after it restarts. By the way, I also mentioned somewhat parenthetically that if you use Dropbox to sync up your projects or your data, and any of your Unity files are in the directories managed by Dropbox, it's always a good idea to turn Dropbox off. I use the until tomorrow setting because I've discovered Unity and Dropbox do not play well together. So it's worth your while to not get into the hair-pulling frustration that can be caused by having Dropbox conflict with Unity. Specifically, you'll get the dreaded error message where a temp directory was unsuccessfully copied to a library. And now we're waiting for Unity to restart. And when I talk about hair pulling, by the way, that's a whole new meaning for me. Ever since the pandemic, I haven't been to the barber, so I never thought I'd have one of these, but there it is. Okay, now I've got a 4-screen setup here, and over this way, Unity is now starting up again. So I'm not just vamping here. I'm actually waiting to see the new Unity, the one that has the input system in it. The input system that we're going to look at, it has several levels of indirection. It's also got some device-specific support. And ordinarily, when you think about a write once and play anywhere platform like Unity, where your runtime project shouldn't be limited to a given platform, you might think, wait, device-specific, that isn't the way we do things. It's actually not a bad idea because they've provided support for all sorts of input gizmos. Some of it they've tried to create abstractions that will let you group them together, so if one player has one thing and another has another, you don't have to rewrite your code. But they've provided enough of it overall that you actually don't feel like you're limited to a specific platform. There are aspects of the new input system that actually provide for runtime adaptation for different types of hardware, especially if you have more than one person connected to the same computer in a multiplayer game. We're not going to deal with that today. We're going to stick with some of the basics, and I'm hoping I'll get as far as showing you how to do a mouse drag. Alrighty, here we are in our beautifully restarted Unity, and if we go down to Input System now and have a look and click on it, first off you can see there's a checkbox here which indicates it's installed in this project. And you'll also see if you scroll down on the right hand side of the package manager window, there are quite a few sample projects available. That's the good news. The bad news is that very few of them seem to cover the sorts of things that I've been seeing in the online forums that people are asking for help on, like the dragging issue that we're going to try to address today. So let's close this. Now we've got our traditional blank Unity project with the sky blue skybox that we're all so fond of. Now I'm going to go over here briefly and look at Edit Project Settings. And we go into the Input package in the Input Manager. If you go into the Input Manager, you may be familiar with this from having set different axes. Well, this time it's going to tell us that we can't use it because right here where we got the stop sign, it's a little tiny print, but I'll read it to you. This is where you can configure the controls to use the Unity Engine.input API. That's the old one. But you have switched input handling to Input System package in your player settings. We'll go have a look at that in a second. The Input Manager will not be used, okay? It's right out. So if we go into our player settings, which we need to get out of the project settings, and we go into preferences. Oh, one second, I think I'm in the wrong place. Let me go back to project settings, Player, yes, and here it is. It was here all along. If you scroll down on the right-hand side, it's a little hard to find, but it's down here in the midst of this section called Other Settings. You see how when you look at the player settings in project settings, there are actually 4 of these drop-down boxes. You want the bottom one called Other Settings. I think it's the bottom one. 4th one up from the bottom, XR Settings. I don't do XR much, so I didn't remember that one. Okay, so in Other Settings, we look down here midway down, and it's a little bit vague. It's under Configuration, Last Entry, Active Input Handling, and it says Input System Package New. By the way, pay special attention to this asterisk. Shared setting between multiple platforms. So this is one where no matter what platform you're building your project for, you pick it once and it affects them all. When you want to know what platform you're setting for, you look up here at the top. There will be more than one tab up here if you've enabled your editor to prepare for more than one platform. I'm simply developing right now for the PC, Mac, and Linux standalone. It's typically all I ever do. Let's look at the drop-down, what our other options are. Input Manager Old, Input System Package New, that's what we just installed with the Package Manager, and both, which we're not going to touch with a 10-foot pole. I personally have a real bee in my bonnet about designating things old and new. How long is something new before it becomes old? I worked at a research lab for a long time where we had a printer called New. Then a new printer showed up, and we decided to call that one New, and you can kind of see where this is going. I haven't had any contact with that lab in almost 40 years. It'd be very interesting to see how many printers they have there that have New and with an exponent or some such thing. All right, so that's all we had to do to enable the new input system. Now, let's add a game object, and we'll start with an empty one. And then we're going to add a component to our game object that allow us to use the new input system. Let's look at input. Now, it's a little uncertain. We've got an on-screen button, an on-screen stick, player input, and a player input manager. Let's try player input since it's near the top. Now it says actions, none, input action asset. Looks like we're going to need an input action asset. Now you can click create actions here and it'll give you a sort of default set. I'm not wild about it, so let's try to do something a little more simple. We'll build up to this one step at a time. We'll pick a few other choices when we get closer to needing to know what they mean. For the sake of it, let's find out what happens if we add the other thing we didn't add, the player input manager. Notification, joining. I think this is not what we're interested in today. We'll come back to this at a future time. We're interested in just simple player input. Now, at the top of the properties, we've got actions. We haven't got any actions yet, and it's telling us that. There are no input actions associated with this input component yet. It says click the button below to create a new set of input actions or drag an existing input actions asset into the field above. I'm going to go with the second choice, and that's just another asset. Now we'll create a folder to store those. Input actions, I think, is the appropriate name. We'll go into that folder. I'll right click, and now we're going to create something. So you go all the way up to the top of the right click menu and pick create, as you always do when you build folders and scripts and everything else. And if you go all the way to the bottom of this thing, you'll see input actions. Now we're going to create some input actions. And I'm going to call this click point, because it's going to be for my click and point interface. You would probably say point and click, so I decided to do something just a little bit more creative. Now, if we double click on that, we get this click point input actions editor. Now, you see there are 3 columns: action maps, actions, and properties. Now, I need to create an action map, so we'll call this one default map. Now notice that a couple of things popped up in the other columns. Now the map, by the way, is simply going to let me literally do a mapping from my input devices to ways that the new system communicates data from the devices to my game. There's several levels of indirection here that involves. We'll go through them. I have to cough every so often, so you'll see me use this thing. If my audio cuts out while I do that, it's not you, it's me. And it's on purpose, so I don't cough your head off. Okay, so we go into the new action. Let's change its name. let's change that name to click. Now, an action is what you're going to be told has happened. It is not what made it happen. It's the level of indirection. You're going to learn, your code and your game is going to be informed that a click occurred. I could have called that anything. I could have called that got mad. I could have called that turned into the Hulk. The real question is, what makes the click action happen? Well, you tell the input actions asset how a click action happens by binding it to, by giving it a binding. It has no binding yet. We can give it a binding by clicking this plus sign. This user interface does not really resemble much that you've worked with before. The closest thing I can think of is the existing event system. We'll come back to that in a minute too. Okay, so we're going to add a binding. And right now it says no binding. So I'm going to actually take out this binding. We don't need it anymore. We've still got this one. Notice when I click on this binding, properties show up on the right. If I click out of it to anything else, it remembers the most recent one, and that can be a little confusing. So we're going to go to this binding. Sorry, when I click up here, you can see it switches to the action. Now, what I want to do when I select the binding is actually bind a physical device input to this action. There can be more than one. You can have any number of bindings associated with an action. The binding I'm going to use is a mouse press. So let's do that. We'll go over to the binding section of the properties column. We will pick a drop down, and you get a nice long list of things that you can use to bind, or that you can bind to that action. So I'll click mouse, and let's try press and see what that does for us. Okay, now this is something important too about this new input system. As you edit this stuff, the edits do not take effect right away. You have to explicitly say save asset, or you can click autosave. I haven't experimented with that much yet. So I click save asset. It takes a moment, but now my binding of the mouse press to the click action in the default map of my click point actions has been saved. So if we go back to, let's close this editor for the time being and go back to our game object. Now we can drag and drop the click point input action asset into this field. Now, it's no accident that I called the default map. You could call your maps anything you want. You can have as many in one set of actions as you like. I haven't reached a point yet where I feel a big need to have more than one, but we may get there. Now, I've got default map chosen. That's the one that becomes active when this action asset, this input action asset is in use. There's a UI input module. I'm not going to do anything with that. A camera, I'm not doing anything with that yet either. Now, something that does matter, behavior. You can send messages, you can broadcast messages, you can invoke Unity events, or you can invoke C# events. Now, it starts you off at send messages. We're not going to spend a lot of time there, but let's look at it since it's first. And right underneath it, we've got something useful. It says, we'll send message to game object. And then it's got a list. On device lost, on device regained, on controls changed. Now, what I would have expected to see here was on click. That doesn't appear to be there. But let's see if we can write some code that'll get that on click message. We'll create a script. Oops. I want to create a folder first to hold my scripts. Hate calling code scripts. Scripts sound so lightweight and meaningless. Computer programs are code. Report. Click. Wait for Visual Studio to open up so we can edit our code. Like everything else is slow. This is not a slow machine either. Okay. If you're going to use the input system, you have to import the namespace. So we'll say using Unity engine input system. Now I'm not making any use of it yet, so it's still grayed out. Let's skip these guys for a little bit. Now it's still not using it, so we're going to have to figure out what it takes to get that message called. Let's have a look back at our input system. Now we see onClick is present in the list. Isn't that interesting? It's a bug in their component editor for the inspector. If we were to take click out, this onClick would go away. Let's see if we can make this available. Maybe it needs to be public. Maybe not. Let's run this program and see if it actually works. We'll save our work. Wait for it to compile. We will drag and drop report click to our game object so the code is there. And let's run our game. Console clears. If I click the mouse, what happens? I got an on-click. That was pretty easy. And notice that it's event-driven. Every time I click the mouse, I get a call to that on-click method, and I don't need a collider. I don't even need a game object that's even visible on the screen, although a collider by itself wouldn't be. So I've already managed to generate input that my code reacts to. Notice, though, that the reaction is not object-specific. It's event-driven, but it's available to any game object that has a player input component on it. And then in turn, that player input component is smart enough to route the events to scripts that have message names on them. So I created a click action. That means that the send message behavior that I've chosen in the player input component results in calling my on-click method. So this is great power for us. Let's add another one. Let's go to the input system again. Let's add another action. Let's call this action explode. Now, again, when you add an action, it starts you off with an entry for a binding. And there actually is no binding there is yet. This time I want to have the explode action occur when I press the letter X on my keyboard. So I go over to the properties side under binding, and I select the drop down next to path, and I could go into the keyboard and tediously look for the letter that I'm interested in, but there's an easier way. Just click the listen button and then press the letter you want, and it gives you some candidates. Now I can click on this, and you can see that under the explode action, it is now bound to the keyboard letter X. Once again, if I want to save this, I have to click the Save Asset. I do that. I close out of the editor. Notice that in the drop-down over here in my project window, underneath my Input Actions asset, if I open that drop-down, my individual actions are listed. I'm not sure how useful that is either. You can see a little bit about them in the inspector, but they don't seem to do much. When we click on the input action assets itself, the inspector shows up something a little more interesting. Generate C# class. We will be coming back to that. I can assure you it is interesting. It's not the biggest thing in the world, but it's a checkbox worth checking. Okay, so now let's go back to our game object. when we look at the player input component in the inspector, notice what we did not have but before that we've got now. In this itty bitty little fine print down here where it says will send message to game object, it lists the messages it'll send just like before. On device lost, we didn't create a device lost action, so we got that one for free. Device regained, on controls changed, those three are always there. They're built into the system. On click was there because we had previously defined a click action. Now we have added an explode action. So on explode will also be called. Let's go into our class and let's add an on explode method. Notice just like the old on mouse downs that relied on colliders and everything else, you are not required to make these public. Whatever trickery Unity used before to be able to call private methods in your C# classes, they're still using it. A lot of people say they're pretty sure it's reflection. I wouldn't be so sure, but more importantly, let me warn you that even if you figure out what it is, if you write code that relies on it, that code is almost certainly going to break someday because Unity has chosen not to publish the mechanism they use to make calls to private methods in your classes. That means they're free to change it. It's supposed to be opaque. We're not supposed to know how it works. So if you write code that relies on your ability to figure it out, you may discover down the road your code doesn't work anymore because Unity made a change that you weren't supposed to see or be affected by. So now we can say void on explode. Notice that does not show up in the list. If there's a way to make it show up in the IntelliSense list, I don't know what it is yet. If anybody knows can tell me, I'd be very interested in hearing from you. Okay, we're going to add a debug. We'll save our work so it compiles. Go back to Unity. Wait for the spinning wheel to tell us compilation is completed. Okay, I should not have to make any additional changes to the game object because I already put an instance of my report click class on it. Remember how Unity works. It serializes the instances, and every time a change is made, it tries to update it. And that's exactly what happened here. Nothing new. So we should be able to run the program, or I like to say start the game. And in the game window, if I click, I can see on click. Now I'm going to press the letter X on my keyboard. On explode. So we have completely succeeded in almost duplicating the behavior of the old input system because now you can use actions you define to send messages to your code. That might be all you need to do. However, notice that it does not necessarily tell you which object the user is trying to interact with. No matter where I click on the screen, I get my onClick method run. And no matter where my mouse cursor is, if I press the letter X, I get on explode. This is an improvement though, because in the old system, if you wanted to read keys, you pretty much had to poll them in an update method. You had to check to see, okay, is there any key down, which one is it, and so forth. This is a tedious mess. There were a few options to support getting whole strings at a time and so forth. We're not going to do anything to replace those today, but if you're looking to create a live keyboard, if you want things to happen when the player is typing the keys as they go, and you don't want to have to make sure that this is associated with a specific game object, this is the way to do it. And it has the advantage that now the mouse downs are going to be read by one piece of code no matter where the mouse down occurs. So that's SendMessage. Now, it works well. It's easy to use. Broadcast message would send these to everybody, regardless of whether or not they had player inputs. And I don't know how useful I think that is. We're not going to devote any time to it today. What we want to do is we want to find out about the Unity events. Now, the reason we want to do that is that Mr. Dom, the guy at Unity who's the chief developer of this, if you look in their video tutorials where they took some online questions a while back, he answers very explicitly, this is the option he wants you to use for production code. But it's got a limitation that I don't like, and we're going to find a way around it. But to do that, we're going to use the C# event option. So let's click that. And now we need to do something we didn't do before. When we look at our input actions asset, we want to click generate C# class. Now it doesn't happen until we click apply, but when we do, we're going to get some stuff for free. Notice what we're going to get. We're going to get a C# class file, and it's telling us right now where that's going to be. It's going to be in the assets folder, like everything else, input actions, the one I created to hold our input actions, and it's going to call that file clickpoint.cs. It's going to be a C# source file named after the input actions asset. It's going to put a class in it called clickpoint, and it's going to define a namespace, except it's using the default global namespace. That's not generally a good idea, but it won't get in the way of what we're trying to do today. All right, let's click apply. We wait a moment. Look what happened. Over in our project window, in the input actions directory, exactly as promised, there is now a clickpoint.c# source code file. Let's have a look at that. Okay, here it is. Now, I had completely forgotten about the @ sign, by the way. C# allows you to prefix identifiers with the @ sign, and that gives you the option to use identifiers that would otherwise be recognized by C# as reserved words. That allows them to safely assume that no matter what you have chosen to call your input actions asset, Unity can go ahead and generate this code file, and it will always be compilable. It would have been a real mess if for some reason I decided to call my input actions asset class. That would then have read up here public class. I think C# would have had a heck of a time compiling that. But by prefixing the class name with an @ sign, that's your warning to the C# compiler that what follows is an identifier. Don't try to interpret it as any other thing. Now you have to use it consistently, so you'll see it again here when they do it for the method name. It's only a coincidence though that they've chosen to make the method name and the class name the same. Well, this is not a method, it's a constructor. That's not a coincidence at all. Now there's a whole bunch of code here, but I'm not sure we have to worry that much about it. What's important though is this. We can see down here toward the bottom that there are a couple of events named after the actions we created, click and explode. And over here, we've got some methods that we'd like to see called. This is absolutely classic, vanilla, nothing special, C# events. If you know how C# events work, that's what's going on here. We'll return to this though because it's going to give us some versatility when we get to using Unity events. What you can see though is that they are reacting, or they are making use of, instances of something somewhere. And the question is what? Well, they're actually talking about instances of this class, clickpoint. So let's see if we can use that to write some code. Let's take the report click component off of our empty game object, and let's create a new piece of code that reports C# events. I'll just call it C# events, report C# events. We'll go into the code. Now what I want to do is I want my start method to create a clickpoint object. Notice that IntelliSense is smart enough at this stage to recognize it, but that's because there's just a clickpoint class elsewhere in my namespace. And we'll go ahead and instantiate one of those. No arguments to the constructor. And now we're going to add a method handler, an event handler. Let's do that here. We're going to say clickpoint dot I think it's default map. No, that isn't it. Let's go back and have a look at the other code. We'll have a look at the settings in the game object, invoke C# events. That's correct. And let's just have a moment to see what the options are. There are no events defined here. No, it is an asset. We'll just keep trying them all until we find it. We're looking for the property that also gives us access to the C# events. In fact, let's just look at the list. Okay, may not be. Isn't it? All right, we're going to resort to the online resources. Let's see if we can find something that'll tell us quickly. I'll look on a separate window so I don't waste your time. Okay, so we're going to work with events. And I created code that did this earlier, so I think what we'll do is look at that older code and see if we can find out how it worked. This will only take a moment, but sometimes this is the fastest way, is to look at something you did in the past and see how this relates to what we're doing now. Waiting for Unity to start up in a separate monitor. Once it's done, we'll be able to query it for what we're trying to find out. Meanwhile, I'll keep looking online. Interesting, it says that there is a property called gameplay. Let's see if we believe that. Yeah, I don't see one called gameplay. Oh, you know what? It might be the name of the map. Yes, and there they are. So here I can say, and I have to give it the name of a method that matches a certain signature. Now you can actually avoid that by simply following using a lambda, and we'll do that now. We're going to say CTX, that stands for context, and then we're going to call the method we want to have this execute. So we'll call this C# event click. Now, C# event click doesn't exist yet, so that isn't a correct assignment of a lambda. Let's define the C# event click method. By the way, we haven't quite gotten to the event yet. Click is a property of default map, which is a property of the click point object. But if we want to actually bind to an event, we have to select one of these. Canceled, performed, started. This is a bit of a mysterious and murky part of the new input system. The events that are associated with input actions come in flavors, if you will. In fact, Unity calls these phases. There's a canceled phase, a performed phase, and a started phase for the click action. And you're probably wondering, well, wait a minute, how can there be a started, performed, click? It just happens. That's it. It's a single event. They treat each of these differently depending upon where in the sequence of clicking the mouse down, holding the mouse down, letting the mouse up. These things get mapped by their input system to different phases. Now, these are the only three phases that a mouse press can be in. Canceled, performed, started. There are more phases than these three in the input system. You need to be aware of that. Check the cough switch. Okay. All right, so I think we can continue with that in mind. Let me open up my monitor so I can be sure I know what I'm putting out to the world. Okay, so now what we've done is we've said we want to add this we didn't set to a phase yet. All right, so we're going to pick one of these events that are named after the phases. Let's go with started and see what happens. Okay, when the started phase of the click action is entered, this delegate will be called by this event. Started is actually now a C# event. So let's go ahead and save our work. Go back to Unity. Now, I took off the report click code. So now when I run, if I click the mouse or press the letter X, nothing should happen. Clicking the mouse, pressing letter X, nothing showing up in the console. Stop the game, add report C# events to the game object. Check that it's there in the inspector. Yes, it is. Start the game. And now when I click on the mouse, nothing happens. Wasn't expecting that. Let's have a look at our code. Let's add the same thing for the other phases. Sorry, I didn't use the cough switch that time. Oh, I left something out. This is not obvious. Got to turn it on. We have a handheld mixer in the kitchen, and there's a switch on it labeled 10, and next to it it says unit must be on to operate. It's probably good thinking for all kinds of computer problems that don't make sense right away. Let's see if this does any good. Okay, game is running. Press the mouse button. Yay! C# event click. Okay. Now, that means that you can do your event-driven programming without having to marry yourself to the Unity SendMessage system. You can do things at the level of C# events. If you've been using C# events for other things, that's going to look awfully appealing. Let's see if we can get a different one into the game. Let's add to the explode event, clickpoint.defaultMap. That's named default map because I named it that. What are my options? Explode. That's available because I created an explode action. Now let's try performed and see what that does for us. We'll explore the others as well in a second. I'm just going to say explode. It takes too long to type C# event explode. Now there is no explode method yet, so we need to add one of those. Notice it can be a private. And we're not using reflection or any other sneaky tricks that Unity might use. Whatever Unity is doing, it's using the standard C# event system to call a method that we added to that event. It's a delegate, but delegates can be private because they'll still be run inside your class. Okay, so we say void explode. And now we're going to just have that say explode. This could do something much more interesting. We're not terribly worried about reacting to these things. What we want to do is show that the input system is communicating with our runtime code. Save the work, go back to Unity. Run the game. Console clears, so if I click the left mouse button, I see the C# event click. I'm going to press the letter X on the keyboard now. Explode. So this is exactly what we wanted. The C# events are dispatching these input actions to any code that we link them to at runtime. So there's quite a number of levels of indirection going on here. When you look at the input action asset in its editor, you can see that there is a map, so we can have more than one mapping. Actions we created. We can call them anything we want. I called them click, explode, but you could call them, feel good. And those names get moved into code the way we saw them a moment ago. You bind actual input from devices. Here I said that I'm binding the mouse press. Notice again, that's a level of abstraction. If I were to say, let's add another one, I'm going to add a binding. Click on this, go into the properties, and select a binding from the drop-down. Notice that in addition to press, there's some rather explicit choices that are a little bit more machine-oriented. And I don't mean computer, I mean the mechanism of the mechanical mouse. If I say right button, now I'm going to get a click a click action for both the mouse press, whatever that is, and the right button, which is much less ambiguous. So let's do a save asset, close that out. Run the game. Now if I press the left mouse button, I get a C# event click. If I press the right mouse button, I get the same action. So it's trivially easy to remap, and the word they use here is bind. It's trivially easy to bind different actual mechanical input options like keys on the keyboard, buttons on the mouse, to actions that the game expects. And the remapping is being done in the Unity editor. My code doesn't need to know that any of this changed. And that's supposed to make it very easy to make your game playable with a variety of input devices without your code having to know the difference. Whether that's a tremendous leap forward over the old input manager or not, you'll have to make that decision for yourself. Notice, by the way, that if I press the letter X, I still get the explode output, so that had no effect on that particular action. I'm going to go into the input actions assets editor, and I'm going to unbind the right mouse button. Save that. Close this. Okay, so far so good. Let's go back now and look at a couple of those phases that we I hate it when this happens. Don't you hate it when that happens? Let's go back and look at the phases that we ignored before. Let's actually bind a different method call to each of the phases. When I say bind, I'm really not using that word correctly because it sounds like I'm referring to binding in the input action editor, and that's not what I'm doing at all. I'm simply adding event manager delegates to the C# event queues that Unity created when it compiled the click point class for me, when it generated the click point class, not compile, when it generated the click point class for me. Now this is a very good way to do things because it's very familiar to C# programmers. But let's now find out what happens if we look at each of those individual phases one by one. I'm going to change the name of C# event click to simply click started, so I know what phase I'm in. I'm going to get rid of the explode code because that's not really relevant to what we're talking about now, and I want to keep this as clean and neat as I possibly can. If you remember, there were two other phases that the click action treats as individual events. So let's get two more of these in here. Let's copy that line of code. Let's take out this reference to the started event and remind ourselves what were our choices, what were our options. Well, there was started, performed, and canceled. They're listed in alphabetical order here, but let's list them in an order that I think is more likely to relate to how we're going to experience them. performed at runtime. And I also want let's find out. I got a typo here. Okay, and now the last one you remember was canceled, so I'm not going to have IntelliSense separate that out, I remember. And we'll change this one to click canceled. This way we can just find out by direct experiment when do they occur or do they ever occur. So we'll need a click performed method. And I'm going to clean up my output from click started so that I use a consistent convention. And we need one more, and I'll just cheat a little bit. We'll copy these 4 lines of code, we'll paste them in, and we'll change performed to canceled. All right, so I've got these 3 event managers being added to these event queues. Let's go back to Unity, run the game, wait for the console to clear. And if I now press the mouse button and release, I get all 3. Click started, click performed, click canceled. Let's break it down a little bit and see if we can get these to come a little bit more separated in time. What I'll do now is the obvious. I'm going to press the left mouse button but not release it. Let's do that now. What did I get? I got click started, immediately followed by click performed. Now I'm going to let up on the mouse button. I'm holding it down. I will let up on the mouse button now. I got click canceled. So it would appear that the started phase is generated for mouse press when the mouse button goes down. For reasons I do not know, they also have the performed phase entered. It is entered after the started phase. You remain in that phase, although no new event occurs. So if there were a way to query for the phase, you'd probably see you were in the performed phase. I don't know that we'll deal with that, but it is possible. You can do it with something called the context. We'll get to that in a bit. And then finally, when you let up on the mouse, you get the click canceled. Let's now do that. Let's re-add the button from the keyboard for the explode event. Now you'll notice I'm using lambdas here and I haven't done anything with that argument, CTX. We'll come back to that. Let's add 3 new delegates, not to the click started, but to the explode action. And I'll do the same thing here. Explode. Now that means I need to add all of those methods. Don't like typing, you may have noticed already I'm not terribly good at it. So I'll simply add 3 more by copying and pasting. And we'll put explode here. I'm going to even cheat on that. I'm going to copy that in and paste it over click here. Oops. I copied click. Sometimes my time-saving techniques take more time than if I just did the long way around. Okay, so explode started. Do that for explode performed. And explode canceled. What do you think is going to happen, by the way? What behavior will we see in terms of the 3 phases? Start, performed. By the way, do we know for sure that there are only those exact phases available for the explode action? Let's find out. If I filter out just the phases, the events, I get the same 3, cancel, perform, started. So it would appear those are the only ones available. Okay, let's save our code, run the game. Start the game up again. And I'm a big believer in making sure that changes don't break things. So first we're going to click the mouse button. Okay, that gave me the same behavior as before. I'm going to clear the console manually. And now I'm going to click the keyboard. And I'm seeing the exact same behavior. If I press down the X key and hold it, I get the started phase event followed immediately by the performed phase event, and then I don't get anything else until I let up. So you now have an event-driven way to react to keyboard input without having to poll it or define an axis or any of the other old silly nonsense. And you can have that dispatched through C# regular events. But you've got to be sensitive to this phase issue. You're not going to get an explode event. You're not going to get a click event. You're going to get a click started event. You're going to get a click performed event. You're going to get a click canceled. I don't think canceled was a very good choice for the phase name. Perhaps there's some other context within which it would make some sense. But when we're talking about keys going down and keys going up, when we're talking about mouse buttons going down and mouse buttons going up, canceled doesn't really strike me as the right thing. So the one thing I want to mention, and we're not going to explore it much today, but we do have one other possibility for what might go in the argument. Remember, we had an argument here, CTX. We could actually pass that to the click started event or to any of the others. You don't have to use a lambda here, by the way, anything that will take a CTX. But the question is, what is that? We're going to get something out of the Unity Engine input system. I believe it's an input action callback context. And that gives you tons and tons of information about what happened when this input action occurred that led to this event being called. So for example, what can we get out of CTX? Well, one of the things we can get is its phase. So let's start our game and click the mouse and hold it. You see what it says? Click started and then started. That's the toString method being implicitly run on the phase member of the context. If we look at the code, this CTX argument is of type input action callback context, and it contains a member called phase. And when you use phase's toString method, which is implicitly done when you list it in the argument list of debug log format, you get back out the word started. Now that means that one method could handle all phases. It could simply query the phase by looking in the callback context to find out what it was. That's kind of a roundabout way to do it, and clearly unnecessary when there are 3 different events that you can ask to have call your event managers based on phase. That's one of the big advantages of doing C# events. When we do this next time, when I give you the next round of talk on this, I'm going to actually use the option we didn't really explore today at all, which was using this behavior, invoke Unity events. When you do that, you get a list of events that are identical to the same Unity events you know from other things where you might have used the Unity event system. But when you add entries, and again, you can add an entry for each of the actions you've defined, click, explode, and here are the others you get for free. Device lost, device regained, controls changed. We're not going to explore those very soon. But you get a whole separate event list for click and a list for explode. But notice what you don't get. You don't get a separate event for each phase. And it turns out, when we do this next time, I'll show you that any methods you put in here get called exactly the same way this click started now gets called. Any phase will generate a Unity event that would call this method if we mapped it in there with the callback context argument supplied, meaning if you want to know what phase you're in, you'll have to query it. What I'm going to show you next time is a way to skip that step in code without having to use the C# events or the C# class that Unity gave us the option to create when we checked the generate C# code. We can still link ourselves directly to Unity events without having to query the phase, but we'll have to do it in code. We won't be able to do it in the input in the Unity editor in the inspector. Okay, I am going to call that a wrap for today. I see that I got 1 or 2 people watching, and I appreciate you being here. I will probably be streaming again on this very same topic. Let me tell you when I think that is likely to be. I think I will probably stream again this Monday, possibly over the weekend. So if you want to follow me so that you get the notification, please do. And thanks for being with me this time, and we will talk about the input system further the next time we're together. Bye-bye.